Hey guys, welcome back to Programming in Objective-C. I'm Yari Dareglia of Jump Zero. In this lesson we walk through dynamic typing and dynamic binding. So far, in the examples, we have written code based on static typing declaration. For example, we have created object using a specific class name. In that case, spaceship. With static typing, we inform the compiler that a variable has a specific type, and this way it can check for errors at compile time. Well, in Objective-C we can use a data type called ID, that is a general type suitable for any kind of object. Be aware that it doesn't need the star, because it is defined as pointer to a sysstruct. This structure contains a single property called isA. That is a pointer to a class that object is an instance of. With the ID data type, we can write generic code. For example, a function that can take as parameter different object types and behave differently depending on them. This is a really powerful feature of Objective-C, and obviously, as for every powerful feature, it can be really dangerous. Let's see some code to better understand it. We instantiate an object from a spaceship class, and now we can create an ID object and assign the spaceship instance to it without errors. This example essentially describes dynamic typing. Dynamic binding brings this procedure one step further by allowing it to send messages to an object regardless of its class. As you can imagine, this operation could be extremely dangerous, and we have to know exactly what we are doing. Let's get back to the previous example. We can write ID object fly. And as you can see, we are allowed to send message described in a spaceship class to a generic object. In this case, ID object contains a spaceship object. But let's see another example. I have prepared a single class called spaceship with a property coordinates described by a string, like 10, 23. Bear with me, this is not the best way to define a position, but it's all you need for this example. And then a method called fire, which lets the spaceship fire at a given position, again described by a string. Now we want to create a generic destroy target, which takes a target object as parameter and uses the method fire with the target coordinates. This is a perfect example of an ID object. In fact, we want to make this function able to receive a big set of possible targets. Let's write its prototype. We don't need a return value, and we take a generic ID as its only parameter, in this case the target. And then we implement it. So we call the method fire on the target position. You must read this call from the innermost function. So first we get the target coordinate, and then we send the message fire with that position as parameter. So this method can be really generic, and the spaceship can fire at many different objects. Let's try it by creating two spaceship instances on the main function. So let's call it a spaceship and, for example, enemy, and defining their coordinates with two strings. So for example, 2140 and 2245. Now, the spaceship can destroy the enemy ship, sending the message destroy target to spaceship. Enemy can respond to the message coordinates, so this call is perfectly valid. But as you remember, this function can accept every data type. So for example, I could use a string as parameter. A string doesn't implement the method coordinates, so if we compile and run, the application will crash. But why the compiler didn't warn us about this problem? Because dynamic binding operations are done at execution time, so we must prevent errors by checking data types and messages during execution. This can be done thanks to introspection, a common practice in object-oriented programming that help us programmatically get information about objects and classes. Okay, we will continue on introspection in the next lesson together with selectors. Bye and thanks for watching.